A very good day to all my audience. I'm Lotan Kiet, a final year engineering student. Today I'm going to present my project, which is Gadget-based smart home system. First of all, there are three research problems that inspire me to build the system. The first one is because the new technology enhanced the functionality and efficiency of the smart home system, but not the usage. They are still using voice command or GUI. Secondly, there's a lot of circumstances that people are not free to access these interfaces, like they are on a call or they are away from the interfaces. Lastly, many elderly and disabled people are still find it difficult to adapt the current smart home system usage. From the research problems, there are three objectives to achieve. The first one is to develop a gesture-based smart home system with camera to assist households' daily life. The second one is to develop an algorithm using IoT to monitor and communicate home appliances with interfaces. The last one is to build a GUI control that can present households' daily life report of their daily informations. The previous research on the related topic can be concluded into four aspects. The first one is the gesture sensor. They are either using a camera sensor or accelerometer. The second aspect is the gesture recognition method. There are three methods that I found from the literature review, which is the first one, the CNN model, the second one, finding control of the image, and the third one is basically just using accelerometer to detect the motions. The third aspect is the device communication techniques. It's either the Wi-Fi or Bluetooth. The last one is the controller. Most of them are using Arduino Uno to control the whole system. Upon the four important aspects in literature reviews, the component selections are going to use the camera and NUT MCU, the Wi-Fi communication technique, and also train the model with CNN training model. As mentioned in objective, this system contains two interfaces. The first one is gesture recognition and the second one is the GUI. The GUI is meant to be the backup interface for the system in case the gesture interface malfunction. The overall block diagram of the system is the hand gesture will be captured by a camera, then the data will be used to train a gesture model. The model is a modified CNN model. Once the model is well trained, it will save into a model file. When new gesture input detections is going on, the trained model will be reload and predict the gestures. The predicted gesture will then control the home appliance and also the door lock. Besides, there is a fingerprint sensor provided for the door locks. For GUI interface, the button on the smart home screen is to control the home appliance and the door lock. Apart from that, there is a DHT22 sensor connected to GUI as well. It is to provide the information of the house. As mentioned just now, the gesture model is trained with CNN model, and there are 7 sets of gesture. Each set will have 15 data training samples. The predictions will only command the home appliance when the probability is above 0.9, which is 90% of accuracy. The GUI interface is built using the Tkinter library. This GUI interface consists of a login system to provide security to the attendant information. Besides, there is a text box to display the DHT22 results. To better illustrate the gesture recognition interface, there is a flowchart shown on the right-hand side. First of all, when the gesture recognition interface starts, the camera will turn on, and the CI model will reconstruct. And when a gesture is shown to the cam, the gesture data input will send into the CI model and compare with the data input. The screen will display the index number and probability of the gesture detected. Once the detections is detecting a probability value above 0.9, and the system will transmit the command to new MCU. When the new MCU is received the commands, the user can either exit the program or continue showing a new gesture finger to the cam. The second one is for the GUI interface. First of all, when the user starts the program, the main screen will generate it. Inside the main screen, there are two buttons, which is the login and also the register. I will first explain the register button. Once the register button is clicked, a register screen will generate. In the register screen, user will have to insert their username and password, and the name and password data will be saved into a user file. Once the registration is done, the user can either register another new account or they can straight away go to the login screen. For example, they choose to go to the login screen. So when they go to the login screen is generated. They will have to insert their pre-registered username and password. The name and password data will be used to verify the enter username and password with saved user files, which means the username and password insert in the login screen will be used to compare with the user files saved in the program. So once the verification is success, the user can now go to the smart home GUI screen. However, if the user type in wrong username or password, the screen will display a user not found, and they will have to insert another new username and password. So when the smart home GUI is successfully generated, the user can now control the home appliance or receive the house information within the screens. All over the screens, which is the main screen, login screen, and also register screen, can be terminated anytime. The last component I will share is the total cost of the project. The table shows is the total cost of the gesture-based smart home system. It is only require 193 ringgit to provide an ECU smart home system for almost everyone. The usage are way more advanced than the existing one, and the camera can be set at anywhere and can be multiple camera in a house to give the commands. With that, the elderly and disabled people can now use simple gesture to command their needs. Thank you. That's all for my presentation, and thank you for your attention and cooperations.